In this video, I'm going to give you another example of how normal functions, in this case combining the left function and the exact function, how normal functions can work together inside of an array formula to answer a question in one step compared to doing it in various steps if you don't use array formulas. So let's go over to our example here. Here we have the requirements. We want to count the number of rows where the first letter in field version code is a capital R, so not just an R, but it has to be capital R. And the second criteria is that the sales price must be greater than 700. So here's our sales price, and both conditions have to be true in order to count that row as meeting our requirement. So you can see if you do it step by step without an array formula, we have to put this formula all the way down the rows, all the way down, to figure out if it's true or false. So here we have a true because it's a capital R, and most of them are false. But second condition, another entire column to determine if the sales price is greater than 700. And then we have a third column here that determines are they both true, and then finally a count if on this column to count the number of trues to get the correct answer of 3. Now it is possible to eliminate this step if we use count ifs, just saying that this column has to be true and this column has to be true. Nevertheless, we still have a lot of formulas all the way down, so we have hundreds of these smaller formulas just to answer this one question here. So technically, this is the correct answer, but as you see over here, we have array formulas that can do it in one step. Now this is, as I mentioned in an earlier video, there are two ways to write array formulas. This is the nested if, where each criteria is an if. So the first if, and then here we have the second if. We can also use the array multiplier syntax, where we just put in the if once, and each condition is separated by the star or the asterisk. It does the exact same thing. They both give us the correct answer of 3. So now I'll just review this a little bit here. Here we are in the first criteria, which goes up to here. We are combining the left and the exact function. It has to be the first character of column A has to be a capital R. So the left function actually just extracts the first character. I can highlight this and I can press the F9 key, and it shows us, it just extracts the first letter. Then that all feeds into the exact function to say, is that letter exactly the same as the capital R? So all of that gives us a bunch of true and false answers. Then we also get another condition here. Is column B, so this column here, is it greater than 700? So this is our second condition. It has to be, all those sales prices have to be greater than 700. So you can see what the second step is replacing this entire column, and the first step over here is replacing the first column. And when both conditions are true, we get a 1. If they're both not true, we get a 0. And then the function of this array just happens to be a sum, and it adds them up. And it gives us our answer of 3. So very similar here, the nested if, it's just a different syntax. In this case, what you do is first condition with an if, a comma, second condition with another if, goes up to here. You don't have to put the ending bracket on. This bracket is just this one and this one. They're just for the left and the exact function. So of course you have to press Control Shift Enter, and it gives you the value of 3, which is the correct answer. Another way you could do this is by, I guess you could use a filter or somehow, but the tricky part is that it has to be capital R, the first letter. You'd have to do a helper column to extract the first letter here, and then somehow to make sure it's a capital R. But using the arrays is much, much quicker. And of course, we go back to the first sheet here, and as they are array formulas, we have to hold down the Control key, hold down the Shift key, and press the Enter key, not the normal Enter that we would do for normal formulas.